any of you here? Hey, we've got two speakers. We've got Debac and we've got Ahmed to us. But Debac is going to talk about how we built a data connector for Sentinel. Ahmed is going to talk to us about generative AI from vectors and tokens to diffusion models. Kicking off now, then we'll have Debac, then we'll have some Q&A and hopefully wrap up about 1:30 to just some housekeeping. The session is going to be recorded. Our point is going to be up on the meetup site soon. I'd like to thank our sponsors, Arinco, pizza that you've all been eating and enjoying. Arinco is award-winning partner of the year 2023 and in the top CRN Fast 50. So thank you very much to Arinco for the pizza. All right, this is our code of conduct. So basically, it's just kind, sympathetic, don't abuse people. Willie. We're here. These are where the coffee places are, fire extinguishers, where the toilets are. So down past reception, past the lifts, men on the left and women on the right. There. So it's fire. Basically, just go down next to the Sofitel Hotel. I'm sure that won't happen, but just in case. Always looking for new speakers. So if you'd like to register your interest, please just at the form and we'll be in touch with you. And if you'd like to give us some feedback about the meeting and what worked. Oh, just a word next meeting, which is in the middle of April. There's a thing called the Azure Global Bootcamp, which is basically everyone around the world takes a weekend or 4 days from Thursday till Sunday to celebrate Azure. And there's events worldwide over that time. Going to session on the Thursday. It starts on Thursday, ends on Sunday. The amazing speakers, and that'll kick off the weekend. And we do another session on the Saturday, which is going to be online only, and you can attend that if you want. Without further ado, and over to Deepak. Anything?
Hello, everyone. My name is Debac. I work as a Senior Cybersecurity Engineer in Diffusion. We are a cybersecurity firm for the last 3-4 years. We focus more on products, suites, and everything around cybersecurity. This presentation is going to be about more focused on Sentinel. We recently built, a year ago, we built a platform we built a plugin connector for Microsoft Sentinel, and we were able to publish it, getting recognized by Microsoft. So I'm going to be covering like a journey of how we started it, what it used to be, what is the problem that we fixed from point A to point B. So the overall idea is, let me give a bit of a context before we start. So people who have been working with Microsoft Sentinel, you might be aware of something called as data connectors. So Sentinel is a SIEM and a SOA platform where you can dump in logs, create detection rules to create alerts and monitor them based on malicious or good behavior. Data connector is a component from Microsoft Sentinel where you can connect from the source platform to the destination. Destination here is the Microsoft Sentinel platform. The key things of a data connector's functionality is the log collection, log ingestion, and the log visualization. So collection is to collect the logs from the source. Ingestion is to ingest the collected logs if you want to do some parsing or whatsoever, do some transformation, and then ingest them into Microsoft Sentinel. And then the third part is the one that I love most about it. There is a log visualization where it shows you a health check saying that there's like some kind of a graph that shows that For the last 7 days, the graph is up spike, or if it's low or it's like standard, it's pretty good. So it's to visually show you the log flow. So with which you can confirm that your data connector is healthy, or if it's broken, or it's just quiet, whatever. So that's the log visualization part. There are two types of data connectors. First one is a functional data connector. Terminology is something that I came up with. There's no proper official terminology, but we hopefully get some soon. The second one is the monitoring data connector. The difference between functional and monitoring is what roles it fulfills in that space. A functional data connector can collect the logs, ingest the logs, as well as visualize the logs that you want to do it. Like a normal data connector that we'd expect to have. Second data connector is the monitoring data connector, where the source platform might not have a capability to do a log collection directly. You might have to go through a different kind of a workaround, like a syslog forwarder or something like that. In that case, you need some kind of an instructions page to say, you need to go to this platform, you need to do this, you need to do that step. And once you do the connection, it's going to automatically logs out. So the data connector by itself is not doing the log collection. There is another third-party platform or an environment or a compute platform that is doing the log collection and log ingestion for you. Those kind of data connectors are called as monitoring data connectors, because all it does is monitor the log flow so you can visualize it. So that's the difference between the functional and the monitoring data connector. Codeless connectors, CCP codeless connector platform, is a component which was announced roughly 2 years ago by Microsoft Sentinel team, where instead of the Microsoft Sentinel team building the data connectors for you, you have the capability to build your own data connector. It's kind of where it's more of like just a JSON representation. You don't have to write any kind of a Python code or anything like that. It's just going to be pretty straightforward. There's really good documentation. I'm happy to share after as well. So with the capability, you can build your own data connector to collect the logs, ingest the logs, and visualize the logs. It supports both functional and monitoring data connectors if you want to build that. The next part I want to discuss about is Cortex XDR as a platform. Cortex XDR is a platform from Palo Alto Networks. It's an extended detection XDR platform for detection and response. It's almost equivalent to Microsoft Defender for endpoint. You put an agent on a machine and it starts monitoring the activities of the machine. If there's any malware or any kind of suspicious behavior that's happening at the device, that's what it's going to start running it. We had a few customers, very few customers who were using Cortex XDR, and that's how I was able to work with the platform by itself. There are 4 types of logs that's supported on the Cortex XDR platform. The first one is the alerts, any kind of a malicious activity that's supposed to happen. Any kind of a malicious activity that's been detected by the platform will be created as an alert. There's just one alert for one device or for one user. It would transition into, or it would be grouped into one single incident. There could be multiple alerts or one single alert that's been grouped into an incident. In theory, incident alert is just a sub-component of the incident that's getting created. Second one is the incident that we spoke about. Third is the audit agent logs, which is kind of like the device logs that are there. So you put in 10 different agents in 10 different devices, and the device activities, the user is opening a file, the user is downloading some kind of a malware whatsoever. All those device logs will be captured as audit agent logs in the machine, on the platform. And the last one is the audit management logs, which is the platform logs by itself, where let's say we have a security analyst who goes into the platform, assigns an incident, manages the incident, closes it off, or deletes some kind of an activity on the platform by itself. That's the audit management logs. That's a bit of a context before we get into the presentation. Yeah, it's a bit too big. Sorry.
Thank you.
It's okay. About these slides. Sorry. So the main area why we had a customer who was using Cortex XDR as their endpoint detection platform, and they wanted to bring the alerts and their device logs into Sentinel. The only possible way at that point of time, which is roughly 2 years ago, is to have a syslog forwarder. So for people who are not aware of syslog forwarder, it's putting a machine on-prem or your network or Azure infrastructure, wherever, to collect logs from the source platform and ingest it to a different device. So it's like forwarding the logs from one platform to another platform. It's good, but it's still a bit old school. This was the solution that we initially proposed to the customer, saying this was the only option that we had. You can have a syslog forwarder. The architecture is about how the syslog forwarder would work. And yes, it does involve a data connector, but only for log visualization. So if you open Microsoft Sentinel, you can see common security logs as the data connector that would satisfy this requirement. And what it would have is it would have an instructions page that says you need to create a virtual machine. You need to configure XYZ on the Cortex XDR. You need to configure XYZ on Microsoft Sentinel, and that would collect the logs from one platform to another platform. It was good, but it still has its few downsides as well, which I'll talk about later. So to summarize this specific solution, it uses a monitoring data connector only for log visualization. So it doesn't do the log collection or the ingestion by itself. Log collection is via TCP, which is something I'm not a big fan of. I like to go through API or HTTP requests, which is much more secure and easy enough for you to control in terms of access. And the third part is it can collect the alerts, incidents, and the device logs from the platform. Alerts by itself alerts and incidents kind of sounds a bit redundant because incident detail will already have your alert detail in that space. So I kind of found it in a way that we don't even need the alerts information in there, maybe for correlated threat hunting if you want to have it on there. But it was working. The downsides that we've seen with this specific solution is that one, it uses an insecure form of collection through TCP. Was something that we weren't a big fan of. That's one of the biggest reasons why we wanted to explore our options to see whether if there's something else we can build. Second was the maintainability. As we said, syslog forwarder involves having a dedicated machine or a virtual machine that you need to have for the log collection and the ingestion. So down the line, the next 2 years, what happens if the machine gets out of date? You need to make sure that someone keeps patching it over and over again. If the machine goes down, who's responsible for that? You need to have a proper SLA on that top of it. So there is a bit of a maintainability, and in the past, we've seen and I've heard as well saying that people will have to have a dedicated full-time employee to just maintain a machine as syslog forwarder. That is something we would try to avoid as well. Third point is the cost that comes up with it. Spinning up a machine, maintaining it, having a full-time employee, all those kind of costs wouldn't come at a free cost. So there would be some cost involved in it, and it was a bit expensive when you consider to just collect incidents from one platform and dump it into another platform. That's where we started digging into the second solution. We wanted to see what other capabilities can we do. Is there any other way we can do? Close enough at the same time, Palo Alto Cortex XDR platform started having API capabilities, which was announced like 6 months ago from the time of it. So we thought, now that it has an API capability, is there a better way to collect the incidents or alerts or device logs from them? We started investing in the good old Logic app, which is an automation capability supported by Azure itself. It runs serverless, so it's very cheap, but it does come at a slight cost if you keep using it over and over again. So what we built initially as an interim solution, we didn't fully go live with it because we'll get to the part later, but the Logic app will be doing the log collection and the log ingestion via API. So it had a dedicated API key and API key ID through which the authentication was done. So it was much more secure, and the automation was running every 5 minutes to see that, cool, is there any new incident? Give me that, and I'm going to ingest it into Sentinel. It was pretty good, but it had a couple of downsides as well. The look back period for the API was really hard to be defined, and any changes on the Cortex side will have to be, you need to manage it on your Logic app as well. Since it's a custom automation, you need to take care of it. Definitely not as hard as taking care of an entire virtual machine to patch it or out of date, all those kind of stuff, but it still has some level of maintainability that you need to take care of. So to summarize, it's still a monitoring data connector because the Logic app is the one that's doing the log collection and the log ingestion. The data connector is just used for visualizing the logs, and that's it. It was good. We wanted to roll out to a customer, and we also saw it was able only to collect incidents because we didn't want to get the alerts because it was a bit redundant in that space. So we went just with incidents at that point. So looking at the downsides of this, it still had a bit of dependencies, whereas to build a Logic app, you would have to have some level of API connections in there, some credentials in there, some access control. So someone has to take care of it. If someone randomly goes into your environment, and disables an API connection that they are not aware that it is connected to that logic app, it's going to break the automation. Someone goes in there, accidentally disables the logic app, it breaks the data connector. You will have no logs in that space. So there was still some level of dependency, which was not as bad as the solution one, but it still has some little bit of downside in there. Second part is, even though it's serverless, it's free. If you start running it at every 1 minute frequency instead of 5 minutes, it would start increasing on the cost, depending on the number of times you use it over and over. Not an entirely bad solution, but it's still pretty good. We wanted to go live with this solution to try and see if we can publish it somewhere so that the community can start using it as well. And that was the same time Microsoft announced a new capability, which was the codeless connector platform, where you can build your own data connector. And we thought, if we can build a data connector, we can remove the dependency issues. We'll be having zero cost in that space as well. Instead of doing the automation on the logic app, we can achieve the same use case on the data connector, which is much more native. So we started investing some time in it, and we built a solution for using the codeless connector platform. 3.1 is what we'll be talking at first. 3.2 is something we've been working for the last 6 months, and we're trying to publish. We'll get there as well. So solution 3.1 is the current codeless connector platform that we built. If you look at this on the architecture diagram, you might see that the log, not just the log visualization, but the log collection and the ingestion is also handled by the data connector. In this case, it doesn't involve a third party or dedicated compute platform that we have to take care of. So the codeless connector platform by itself is a compute platform. Codeless connector platform by itself is a compute platform that can do the automation for you. Benefit is that it does all three: collection, ingestion, and visualization. The biggest benefit that I see is that if there is some changes in the Sentinel level, or there's some kind of a data that's format that's been changed, everything is abstracted on the Microsoft end. So there's very less accountability for us to change the data parsing or whatsoever, because Microsoft will be handling that in their backend every time there's some data structure that's getting changed in there. Let's say there's some permission changes. Instead of Microsoft Sentinel contributor, you can just use Microsoft Sentinel responder, which is a lesser permission in that space. I don't have to manage their permissions. It's all handled on the backend by the Sentinel engineering team. So it's very less accountability for me to keep managing the data connector. So that was the biggest benefit that we loved there. The log collection is again via HTTP, which uses the API key and the API key ID. So much more secure than using a TCP protocol to just dump the logs in there. Even for this data connector, we only built at that point to collect incidents, and that's it. Because from our customer requirement, it was more of, I just need the visibility for the incidents. Anything as a device log, I'm happy to go into the original platform to do the threat hunting in that space. I don't need to bring all the logs to Sentinel to do the threat hunting here. So we built it in a way that it just supports incidents. So that's the codeless connector platform that we built. And what we wanted to do is not just keep it with us, and we wanted to publish it somewhere so that the community can start using it as well. For people who are not aware of something called Content Hub, it's kind of like a marketplace for Microsoft Sentinel. So you have Azure Marketplace. Similar to that, you have a dedicated marketplace for Microsoft Sentinel by itself, where you can people can publish their own solutions. It has to come from reputed vendors, or people will be evaluating the solutions to make sure if it's good, if it's bad, and it's all free at the moment. There's no cost. There's nothing you'll have to charge or whatever. It's more for the benefit of the organizations as well as for the platform by itself. So we started investing time in trying to publish a solution at that point. We had heaps of support from Microsoft. Shout out, thanks to so many people out there. Right now, a couple months ago, we double checked how many organizations have been using our data connector that we published in Microsoft Sentinel, and roughly it was 118 individual organizations that's using the connectors. So that was actually a pretty good feel-good thing for us to see that data connector that we built has been used across the globe by 100+ organizations. So that's something up there. For brag, Diffusion is the first MSSP or organization across the whole globe to publish a solution in the Sentinel's Content Hub for a product that is not owned by us. So the product, the Cortex XDR, isn't something that's our own product. So Palo Alto by itself has published a solution for a different product, but it's their own product that they published the solution for. So Diffusion is the first company across the globe to do something from an MSSP perspective to support the community and stuff. So where can you find it? If you go to Microsoft Sentinel, any Sentinel across anywhere, any customer, any organization, you can go to Content Hub. You would be able to see lists of all the solutions. You can filter either by the provider name as different, or you can just search it directly as Cortex XDR, and you'll be able to see the data connector that we published. It's still really good. We intend to improve this moving forward as well, which is the version 2 that we are trying to publish right now, which would be soon, like in a couple months' time, we would be publishing that. So that's the overall current solution that we have in place for Cortex XDR. The second solution that we started building is, of course, nothing ends at, there's no such thing as destination. We need to keep improving it over and over again. We had a couple of requirements from customers as well as from Microsoft saying that now that people are starting to use the solution, they're asking much more requirements saying that, would you be able to collect not just the incidents, but also the device logs as well? I want it on the Sentinel so I can do some correlated threat hunting instead of me going back to Cortex XDR platform to do the threat hunting. So I can do it all in one single place. So that was the requirement we had. We're like, cool, let's try and start building that. People who's working with Sentinel, you might know that there's 2 different types of log ingestion methods. And the old one is getting deprecated around early 2026, which uses workspace ID and workspace key. The new one is called Log Ingestion API, which is much more secure. It is handled via managed identity or a service principal for the authentication side. We're thinking if there was a way to use a codeless connector that uses the new method of log ingestion to support that. And we started asking questions of people. And I still remember one of the engineering team member from the Sentinel, Microsoft Sentinel engineering team said that you're just so nosy around it. You're smelling every single private preview stuff. So there's already a private preview in progress on the roadmap. They're already building some stuff. So they gave us a preview access, like a pre-preview access on that, saying that, cool, this is how we are building it. We still haven't got to that part. So maturity, and from a perspective, we were helping them saying that, cool, we're going to build something on that. We're going to test it. We're going to give you a feedback. We worked with them, and the team was really amazing. They were really responsive on that, and they helped us build the data connector as well.
Well done.
Yeah, it's pretty good. So the benefit of this specific data connector that I love most about is the extra part that you have for filtering, where it doesn't just ingest your logs directly into Microsoft Sentinel, but it passes through something called as data collection rule, where you could filter the logs and say that, let's say you have 10,000 devices, out of which 1,000 devices are test devices that you don't want to collect the logs from. So you can save some money on that. What you could do is you can put a filtering in there that says, if the device name starts with test dash whatsoever, I don't want you to ingest them. Or you can have any kind of a condition that you write using your KQL syntax. So it can do data transfer. It's not just for log collection, ingestion, and visualization, but it also supports log transformation, which is the biggest part I love about this data connector. So I didn't mention that, did I? Yeah, log filtering and manipulation. So it can do the filtering and manipulation for that as well. So apart from that, like I said, people start asking us about the device logs as well. So what we are doing right now is, instead of publishing one data connector, we are now publishing 3 data connectors, one for each. Initially, we started building one data connector for all the 3 log types together, saying that we just click one connect button and it'll automatically ingest the incidents, device logs, and the platform logs together. But we had some feedback saying that, what if one of the customer doesn't want the audit logs? What if one of the customer doesn't want the device log, but wants the audit logs in that space? So to have the flexibility, we've broken that down into 3.2.2, where we have one data connector for each log type. So the new solution will be coming up with 3 data connectors in total, one for each, where it has the first one is for the incident that supports the same log collection, ingestion, visualization, and filtering to get into the log analytics workspace. The second one for the device logs, and third one for the platform logs as well. So we're still working in progress. We're getting there. It's almost done. We've tested it as a proof of concept. It's pretty good, but we're having a couple of bug fixes that we are trying to finish it off. And once that's done, a couple months time, hopefully, we will be having this new solution in place as well. So that's the new codeless connector. So if you look at a higher picture, you can see starting from solution 1, which was a syslog forwarder, really old school through a TCP, and the second solution moved to a HTTP, where API collection, but it's still a custom automation that you build. And then the third solution is where you have something abstracted so that you have very less accountability on your automations, Microsoft Sentinel engineering team will be taking care of the whole backend on that space. So that is much more native. And the fourth one is not just from collection, ingestion, and visualization, but you also have filtering and transformation, which is much more beneficial on that as well. So that was the entire journey from end to end for Cortex 1 point to another point. Might finish it off early. That's my LinkedIn. I've wrote a couple of articles about the data connector by itself, all the different types of the log ingestions that we put in there. So people hit me up, and I'm happy to catch up with you guys if you have any questions on that space as well. Any questions now?
Is a question online? Yeah.
It was Luke asking where to host.
Thanks.
Luke is saying, where is it hosted? Your own environment, your customer tenancy. Is it a connector as a service, or host your own connector?
It's as part of the customer's environment we host it. So we don't, as an MSSP, we don't want to host customers data connector where it does the log collection ingestion. So whoever the customer is in this space, let's say if I'm a customer, I will be building my own Sentinel. I can just go into the Content Hub, click, click, click. You don't have to build your own, just a couple of clicks to install. Probably API key ID. Everything stays inside your tenant, inside your subscription, inside your resource group. So nothing is handled by anyone else in that space.
Thought about running this as a service.
We want to keep it open as in terms of our community to use it.
I mean, putting it up so that people can subscribe to it and use it instead of hosting.
No, so when we say hosting, there's no specific resource that's getting involved. So in Content Hub, it's kind of like a marketplace. You just click install, and it's kind of like a service that sits on your backend to run on top of it. So it just runs in your resource group rather than not like a dedicated hosting that you need to take care of.
Can you talk briefly about the dev experience for creating that connector?
Oh, yeah. Yeah. It was painful. So, so when we started, it was not a popular thing. So we had very few documentations at that point. Most of it was brute force and trial and error method where we tried different options to get it. One space that we got really, really stuck on was we were able to get a response, but there was no. The response had a dedicated parameter called incidents, inside which you had the columns. So the output of the schema and the one that we're getting there didn't match in there. So you had to go one more level inside the response to actually get it out of it. So which was really hard for us to find out. By the time we finished in the next couple months, I think the engineering team had a really good documentation come up, and they had the exact same thing that we did. The biggest benefit, and again, I want to shout out to a bunch of people from the engineering team, like Benjamin Kovacevic or Mauer Yona and Oded Weber. We started, so there's a community called CCP, CSP, I don't know, from a private preview community. So we were able to reach out to a bunch of people asking for assist, and we jumped on a call with them, and they were helping us with the private documentation saying that this is how it works, this is what you're trying to achieve. But they weren't aware about the Cortex XDR API platform, which is something that we were aware of, but we weren't aware of their data connector platform. So it was a mutual situation where we helped each other. So it was pretty good, and wouldn't have happened without those people. The second challenging part was publishing into the Content Hub solution. When we started, there was no such thing as publishing into Content Hub as well. It was a really premature documentation that was around there. No one has done that apart from Microsoft by themselves. And we got a couple of people, Pablo and Pratik Taneja from the engineering team as well. So they were helping us saying that, cool, these are the things that happens. You need to do a couple of license checks, like how are you going to publish it? Is it a free solution? As of now, there's no way to publish it as a charge solution because Azure Marketplace has a paid plan, which is a free plan. But in Content Hub, it's purely a free plan at that point. We're not doing this for money. It's more for us to contribute to the communities, make sure that people can start using that as well. So it was definitely a mutual and a helpful thing from Microsoft as well. That would sum up my whole journey, I would say.
Is it like a low code, no code environment?
Correct. Yeah, it is an entirely low code. I wouldn't say there's a no code, but it's a low code.
What is the code?
It's just a JSON. If you're familiar with the ARM templates in the Azure environment, it's pretty good, same as that. Yeah.
Okay, cool.
It's just given JSON blobs of whatever you want to do it, and it's say, this is for the definition of the UI. I need to give this value for instructions. I need to give this value for the type of the data. and it automatically does the thing on the back end. So we don't have to write the code on that.
It's not XML anymore.
It's not XML, it's code. Now, people who are familiar with ARM templates would definitely find it very easy to build data connectors. If you have been working with Azure and if you're familiar with Sentinel, it's pretty much straightforward, I would say.
Thank you.
Thank you. And now we've got Ahmed to talk about generative AI.
Never heard of it.
If this is going to work. People online, can you see my?
Got
Yep.
a thumbs.
And can we click stop or have a clicker?
Clicker.
No.
I do have a. Right. Hope it's got batteries. It's got batteries.
So,
Just
To
plug the USB in.
plug in the USB.
oh, sorry. Oh, in the device.
Into your machine, and then it will.
Oh,
Pretty quick.
only have USB-C, unfortunately. Oh, that's
Funny.
all good, man. No worries. I'll use that. Great. So, hey everyone. I'm Ahmed, and I'm a cloud consultant at a company called CCL, and I'm also an MVP. I do blog and stuff on social media, YouTube, and Twitter and LinkedIn. And today I will be talking about some of the basic concepts that actually bugged me when I'm trying to understand generative AI. And a lot of the terminology that I will be talking about today is, I will only talk about how do you understand it, not talking about anything mathematical. Not going to go into the deep details of like the science behind it, but I feel that it is actually stopping a lot of us when we try to understand what is this new LLM or generative AI, and I'm already starting to use some terminology. So, but when you abstract it to the basic, it is actually quite easy to understand what is it that we are trying to solve, and how did it actually, in a way, how did we teach the machine to actually think? So the first thing that I want to talk about is that the idea of LLM. So LLM stands for large language model. And the idea is that computers actually do not understand characters. They do understand numbers. So the first thing that if you want to teach a computer to think and talk, not say talk, yeah, okay, to actually understand your text and give you text back is to convert those numbers into characters into numbers. So for the sake of an example, let's say that you've got like English dictionary, and then you start with giving each word a number. So like you start from A to Z, and then say like the first, of course, this may be not the first letter and not the first word in the English dictionary, but for example, say it is the first one. So you say, okay, so about, you give it 1, above you give it 2, across 3, and so on and so forth, till you reach the end of the dictionary, and then you give the word 0, 600,000 or whatever, right? So this way, this is an understanding that we first came up with, which is like turn the characters, turn words into numbers, and then start with using all the beauty of math with statistics and probability. And then whatever mathematical equations you were able to run on numbers, you will be able to now run on words and characters. So for example, the word, hey, how are you, could be turned into 5, 25, 30, whatever. Of course, numbers will be so much high up, but for the sake of example, we'll use like small numbers. So basically you started to represent your words and characters with numbers. So what comes behind the scene is that actually instead of numbers, one other concept when we are jumping into the world of Gen AI or LLMs is the idea of a token. And for example, you hear that ChatGPT has got like 128 or 200K token size, and then more and more each new model are saying like the context window or the number of tokens the generative AI could actually take is increasing. So if you, for example, if you jump into this website, which is ticktokenizer.vercel.app, and you'll get this window, whatever you put in this window, it will turn to numbers. And the idea is that each color here, the large language model actually, and the algorithm that tokenize your text actually turn into a number. So for example, this word like lim_start, it turns into 100,264. And then after that, the word system is 9,125, and so on and so forth. The idea is that we are trying to use math and trying to use what a computer actually understands. So we turn those words into tokens. And as you see, sometimes the token is not just one word. So for example, in here I said like hello Aotearoa Azure, the space before the A and the character A is one token. Then you have the OT as one other token, EAR, and so on and so forth. So there is some algorithm that goes behind this and then tokenizes your words and characters. It is like the more algorithm, new versions of an algorithm, the more it becomes smart in tokenizing your characters and even your code. So the first step is to teach your computer is first tokenize your characters and then turn it into numbers, use those numbers, and then start to use whatever math that we already have. Okay, so now what is the LLM do, or like how does it actually work? So the LLM work by predicting one word at a time. So for example, say that you give an LLM the word R, and they say, can you predict the next word? And because the LLM has been trained on the whole internet data, it actually has some statistics of saying like, okay, in the whole of the internet, I have found the word R, or maybe the number 5. And again, we are just simplifying the representation of the characters. I've seen the number 5 and 75, which is RU, 5% of the time. And that is out of 100. And then I have seen are they, which is, for example, if a sentence is like, how are they? You would say it is 5% of the time. And then are things, another 5% are fine, and so on and so forth. So out of a big set of data, which is the whole internet, the LLM has actually, we have given the LLM all this data, and then turned this data into numbers. And then using statistics and probability, the LLM has actually found out that if you have only 2 words, which is called tugram, if you only have 2 words, and you have set of those 2 words, it has seen the RU 5% of the time. So if you are asking the LLM, can you predict what is the next word that comes after the word R? It would either give you RU, are they, are things. It depends on like what is the statistics, but how accurate is it? Is it the thing that you want? It will be a hit and miss because you are just giving it one word. And then you're asking it to, can you complete this word? Okay. We take it a step further and then say like, we give it now 2 words. And the context now is 2 words. And we are saying like, can you predict the next word? So the context window is only 2, but as you could see here, the probability is so much different now, because if you just say like, how are, the word you has happened 50% of the time, because now it is like much more accurate because it knows more than what is it that you're trying to say. So instead of just saying are before, which was like, are you, are they, 5%, I don't know. But now the word how are you is like, oh yeah, I've seen this one half the time. Each time I see the word how are, there's very high possibility, 50%, that it is actually. And there is also 30% here, for example, they, you could say like, how are they doing, right? So it has seen this combination, how are they, 30% of the time. But again, it is still hit and miss. It is very low probability that is like to say the word how are animals. It might have found it in the context of its training data, but it's really low. So it's not going to go and predict the next word to be how are animals. We take it another step further. Now say, hey, how are you? And then ask it to predict the next word. And now the you is really high, but the they, which was 30% before that, it's now 5%, because you don't say in the internet, hey, how are they, right? You would say, hey, how are things, which is now increased 10%. So as you could see here, the more context you give the LLM, the more accurate it is to predict what is the next word and what is it that you're trying to do. So for example, if you give the LLM, which is the ChatGPT level, sometimes if you give it the context of 1,000 words, 100,000 words, right? It would actually very accurately predict what is the next word, even if the next word could be something really unlikely. So because of the context, so like, let's say, for example, you are talking about mountains, or there's a story about cars. And then you give the context, the idea of, the LLM, the idea is saying that, hey, and then she goes to, and then you give it a space. And then the actual word is she goes to the moon. And it's like, goes to the moon? Why would she go to the moon? But if you go and read the whole context, it's all about the space. And she's like planning to go there and then taking all that time and then find a word, and then she goes to the moon. So, if you look at it now, I might be giving you the idea is that the LLM is just statistics and it's just probability. It's just predicting what is the next word. So why is it that we've only came up with it very recently? And why didn't we just use that before? The reason is that if you take this idea of like 1 gram, 2 gram, and 4, and so on, if you take it more and more, it becomes really computationally and memory intensive to actually build that on a computer. Because let's say that we are talking about, we just said that the English dictionary is 600,000 words, right? So if you say that our vocabulary is 10,000, right? It's not 600, just 10,000 words. And then you put that in an Excel sheet, and then you say, okay, so I'll put a word out of all these 10,000 in each row. And then in front of that word, I'll put another, in each column, I'll put 1 word of all these 10,000 words. So your Excel sheet is 10,000 by 10,000, because these are all the probabilities, right? And now you've got this, 100 million cells of an Excel sheet. That's a lot. Right? We're only talking about 2 words. If you add another word, that is another 10,000 by 100 million, so you are almost reaching a trillion word. So you could see how if you go here, it becomes really computationally difficult and memory intensive as well, because if you add more and more words, it becomes really hard for the computer, and when you store it, to actually predict what's the next word. So for example, we had autocomplete within programming, we had autocomplete on our iPhones. It is all good. It's not using LLMs, which is what this is all about. But what we couldn't do is that we couldn't do it on the context of like say, okay, so you give it a sentence that is like say 100 words, and they say, can you predict what is the next word? It would have you would have, in theory, it's so easy, but in practical, it's really hard. You can't actually build it on a practical computer. So in 2017, a paper came out, and it was called "Attention is All You Need." The idea is that this is a transformer, which is the T in the GPT. And you don't need to understand what is this, and it is mathematically a bit difficult. But all you need to do is all you need to understand, which is something I'll tell you about, is that there is a very interesting trick that the transformer is doing, is that it is teaching the LLM to actually give weights to words. So not every word gets the same weight. I'll explain that in a second. So say that you have this sentence, right? So like, my dog's name is Ben. He's a big dog. Ben likes to play fetch with me, right? So you give this sentence to the LLM with the using of a transformer, right? So this is a long sentence, and we are in here on the word play, and we are asking the LLM to say like, can you predict the next word, right? So what the LLM is doing is that with the transformer, it is giving weight to all these words, and it knows by training on a big context of data which word it should actually give weight to, which one is the most important word in here. So it knows in the first sentence that Ben and dog are the same. It knows that Ben is actually a dog. So in the next sentence, when you say Ben likes to play, he's not gonna want to play football because he's a dog. So the LLM is predicting that, okay, so Ben is a dog, and Ben would like to play what? So it would most likely say, I would like to play fetch. So it will predict that the next most probable word to complete this sentence is the word fetch, instead of it saying soccer or whatever. So all you need here, so this is actually the big breakthrough moment that came out in 2017, is that instead of giving every single word in here a context, and if instead, it's actually really good that it could infer what is the whole paragraph, sometimes even more, that it could infer what is it that you're trying to say, and then predicting that actually the most suitable next word should be something like fetch. So that is where the big change happened. That is where everybody was like, oh, this is like a big breakthrough. And then people started to think that this is good. This is something that we could actually build on top of. Okay?
Were they already doing that in 2010, 2012?
You mean Grammarly or?
And grammar, so suggestions on grammar, for example, and what words to use, because I'm a wordy guy. I like to talk and do something, but I found out though that I talk way too much. Once I started using grammar properly within Word, then suddenly I realized that I needed to change how I spoke, and so I did.
Yeah. So sorry.
This is almost, to me, it appears to be the same thing.
Yeah. So that's a very good question. The idea is that when you're talking about the grammar, it is so like I talked about it in a very simplistic way about autocomplete. So the rule is that if you give in the context of the word hey or like how are you, you would just be using like your statistic and saying. But with grammar, it is still using statistics and probability, but they're adding more and more rules. Say like, okay, if like it's not just a word after a word, this word needs to have some extra conditions and actions. So it is still using probability and statistics, but it doesn't understand the grammar. And when I say the LLM understand, it doesn't understand because what you'll see when I'll go through this is that it's all numbers and it's all correlation. but it gives you the indication as if it is actually understanding what you are saying. So like with the grammar, using, for example, ChatGPT, you give it a sentence and it's like, why is this grammatically wrong? It would tell you why. That is different on a different level. This is what the attention is all you need. So it made it scalable, made it possible to actually come up with such answers. But there is a lot more that was built on top of this that make it gave us the ChatGPT 3, 3.5, and 4.
So when you're typing in Bing and you're going, how was the weather will come up without you even typing it. So is that?
Oh no, that's autocomplete. That's like when you go to Bing and it's like.
I'm using it like not on the phone because
the autocomplete
phones are automatically.
Yeah, that's not LLM. Yeah, that's not using LLM. Yeah. So now I want to explain one concept which is I actually touched upon here, which is that when it starts to generate language, what it is actually doing, it is always predicting the next word. I talked about it briefly here. So for example, when you say like, how are you? And then you give it 3 dots, it says like there is a 60% likely that the word is I, because like, how are you? I am fine. Or it says like, we are good. Oh, thank you. Something like that. It goes through probability, but then the next word, again, you say like, okay, how are you? And then I. And then now the most likely word is different. It is the word am. And it goes on until it goes into the level where it says, I'm fine. So where I'm going with this is that if the LLM is really predictable, so if the LLM is like each time you ask it, like, how are you? I am fine. Like if you ask it to complete it and it's always giving you, how are you? I am fine. That's not so interesting. That's not so creative. So like if you ask right now, if you go to ChatGPT and ask it a question, then ask it later on the same question, it will give you a different answer each time. It's not the same answer. And there is something that goes behind the scene that is causing this what we call a creativity, or like it's not giving me the same answer every single time. So the problem that the transporter model actually solved is that made it computationally possible to actually build on top of this. But then we started to add more and more intelligence to it, so until it became what is it right now. So I want to now talk about the idea, which is the temperature. So the temperature here, we are talking about. Just say that if we ask the LLM to say how are, and then it says like my most likely answer is you. So how do we make sure that it doesn't give me the same answer each time, and otherwise it will become really boring? So we came up with a concept called the temperature. So the temperature is between 0 and 1, with 0 being completely predictable, always giving you the same answer. So like if you say, give me the 10 most common name in New Zealand, it would, if you have it on 0, it will always give you the same answer, no matter how many times you ask it. But if you raise the temperature all the way high to number 1 and then say, what are the most common names in New Zealand, it would start to give you names from all over the world. Because that's what we call it, it is start to hallucinate. Because the creativity temperature here is really high, it start to go and then say, instead of saying, how are you, it says like, why don't we say, how are they? Or how are things? And that's why it becomes creative. That's where we get the surprise of saying, the word. And I was like, oh, it is actually creative. That is one of the things, for example, if you ask ChatGPT to give you a poem, it would go and give you a poem that's literally never been created before, because of this calibration of temperature, that it is not giving you the same answer that it's seen on its training data. So as I said, the more high the temperature, the more it starts to give unreasonable things like how are animals, because you are increasing the temperature and it starts to hallucinate. Okay, So we are halfway through. Now, so like we are in a place, and this is from the OpenAI blog, when they released ChatGPT, or GPT, I should say, 3.5. So you don't need to go, like you don't need to like focus a lot on what is it, what is the supervised fine tuning, sorry. The idea is that we created this model that is actually really good in completing the next word, right? So like the model would, you would give the model a sentence and it would say, okay, this is the next word. Give it a longer sentence, keep on doing that until it gives you the end of sentence. The problem with that is that this is not so useful. It is, you call it autocomplete on steroid. It is really good in predicting what's the next word, but you get no value out of it. What you want, which is the ChatGPT experience, where you want to ask it a question and then it gives you an answer. So when we finish training the LLM on all the data on the internet and the base model, it knows everything on the internet. It's got a lot of data. You wanted to say, for example, you wanted to give you an answer to questions. So what we did is that ask a bunch of people to create, say, 1,000, 10,000 document of a question and an answer, and then you give it to the model and then say you train it a little bit. It's not going to forget whatever it trained already on, but you just train it on this new piece of data, which is fine tuning. And I know yes, all people asking is that, can I fine tune it on my model, on my data, sorry. Yeah, so like you give it this question and answer, and then it starts to learn not a new information, it starts to learn a new behavior. So it knows that each time there is a sentence that translates to numbers and then understand that this is a question, there's always something that comes after that, which is the answer. So you give it more and more questions and answers, question and answer, and I was like, oh, I get it, I get this. When I see a question, next time I'll give you an answer. So what happens here is now all of a sudden, the autocomplete on steroid, or like the LLM, which is really good in predicting what is the next word, it now became useful because now you could ask it, where is the like size of the earth, or like who's the president of whatever, it would give you an answer because it learned when it sees this behavior of a question that there is an answer that needs to follow. So that's all good. And now the model is really good in giving you like an answer to a question. The issue is, what happens if the model gives you an answer that you don't want? So if someone says, like, how can I create a poison or whatever? You don't want the model to actually just say like, oh yeah, of course, this is how we do it, because it knows that after a question, there should be an answer. It doesn't have a value. It doesn't have good or bad. It doesn't know dangerous. It doesn't know things that it should not do. That's when and I keep on saying we, that's when people at the OpenAI and other organizations came up with the idea of reinforcement learning with human feedback. So the idea is that you give a bunch of people, 1,000 or more, access to this model, and then say like, you would ask it a question, then it would answer, and then if it is a good answer, or if the answer is like, how do you create a poison, and then it would give you the answer, you would say, do you tell it, like give a feedback to the model saying like, bad model, that's not good, don't do that. And it would have a punishment and a reward function built into it. And the model is just looking for the reward. The model is like desperately trying to get this is something programmed into it. So it needs to get the score high. It needs to be rewarded, right? So thumbs up. Yes, exactly. So you ask it the question again. I was like, how do you create a poison? I was like, sorry, I'm a large language model. I can't answer this question. So the question is here, why was everyone surprised? Why was this big jump when we came up with, when the ChatGPT, I think was a year ago, 2 years ago? Yeah, something like that. When it was released to the world, everybody was surprised. It's because of three things. The first thing, which was the scale and speed. So with more, this is something that scientists realized and people working on the LLM is that with more scale, with more access to compute and memory and underlying infrastructure being more powerful, the model started to internalize a lot of concepts that we didn't know that it actually could internalize. So it would internalize the idea of a question or an answer, the behavior of if you get a question, you need to have an answer. So that was something that came out of scale. The other thing, which is the simple idea, again, it's simple in theory, the idea of temperature. So like this idea unlocked the idea of creativity, which was also surprising because a lot of people thought that if you came up with the idea of whatever artificial intelligence, creativity would be the last thing that the AI would actually unlock. But with this simple idea, we unlock the idea of creativity, just increase the temperature and it will give you a surprising answer. And then finally, the idea of steering the model with fine-tuning the model with data that you wanted to give an answer for, and again with the idea of reinforcement feedback, reinforcement learning human feedback. So how am I doing in time? It's like half an Can I keep on?
Yep, you're good.
Yeah, you still got time.
Okay, good. So now we come up to another concept, which is also something that actually helped us unlock the idea of unlock the idea of like the language being able to search in a very big amount of data and then coming up with answers so quickly, which is the idea of a vector database. So this is from this blog, and the idea is that if you have masculinity and femininity and then royalty, each in a like if you have a wall that only have 3 domains, right? You have royalty, masculinity, and then femininity. And then you have the word king, and then you put the word king on a scale, and then you measure this word and compare it to this domain, each domain, right? So before I go into the details, what are we trying to do with this vector database? We are trying to teach the model, or like we are trying to teach the computer, I should say, the idea of meaning. So instead of it just knowing that, so like I just said that, for example, a pen and a dog, they are the same because it's because of the intention. It's the idea is that we want to train the computer to actually make inference and make correlation between things that might sound or like on a scale of data might sound different, but when it starts to realize that they are the same, it would figure out, oh, actually king is related to queen and to a woman and to a princess. So how did we do that? So the idea is that we said, okay, for a king, royalty, it's 99%, masculinity, it's 99%, and femininity is 0.05. And the reason that these are like not 100s and zeros, because in statistics, doesn't work this way. You always have to have a room for error. And then you go again, the queen is 99%, masculinity is 0.05, and femininity 93, and then so on and so forth. So now you translate it on this world with 3 domains. You translated things like king, queen, women, and princess into numbers, into things that the computer could actually understand. So, and then you add another layer. So for example, in here, we've got the king, and then we've got the man. So like how much is the possibility for a man to be a king or a royalty? That is really low. How many people in the population are actually kings? It's very low. Masculinity is the same, and femininity is the same. But what's really interesting is that we could now, because we turned those characters, those words into meanings, and the meaning of it into numbers, sorry, we can now start to do mathematical equation on them. So if we say, okay, so we've got the king and the man, if we multiply the value of the numbers that we associated with the word king from the value of the number we associated with the word man, we get something else, which is if 0.99 minus 0.01, it's 98. 99 minus 99 is 0. 0.05 minus 0.05 is 0. So this is 0, and this is 0, and this is 98%. So you get the idea that if you take the man out of the king, you are only left with the idea of royalty. Let's, yeah. So we take it a step further, and then now say like, okay, we've got royalty. Let's add in the values for a woman, and you get where I'm going with this, which is 0.98 plus 0.02, 0 plus 0.1, 0.999, end up with a queen. So we took the meaning of the word king, we took the man out of that word, we ended up with royalty, added the woman, ended up with a queen. So this way, what happened is you could actually represent everything, everything in the world with numbers, and those numbers could be on a vector. So for example, you've got the word king and a man, queen and a woman. If you take the word king and abstract man from it, you get the word queen if you add women to it. So with this abstraction level, we are now teaching the model to even infer what those words are. It's not just going through the database and saying like, okay, I found that R and U actually come together a lot of the time, and R and fine. It's actually going even a step further, because it now start to infer things that is surprising to us, because we taught the computer what is the meaning out of associated with each of those words. If we take this one a step further, the computer, the LLM, start to actually connect stuff that are very surprising, but also for us human is very intuitive, and it's not very surprising. So like the lion is the king of the jungle, tiger hunts in the forest. It knows that these guys are actually close to each other, because you could subtract and multiply and get from a lion to a tiger, jungle to a forest. These are together, but this one is far away because it doesn't have anything similar or related. And the vector actually doesn't just relate one word to another. It actually could actually relate whole concept, like thousands and thousands of words with one with another. So like when you ask a ChatGPT, or like I keep on saying ChatGPT, but when you ask the LLM, it would actually give you a lot of answer that is very thoughtful. It was like, oh, it actually brought all these ideas together. It's because we are giving it those skills, and because we are using things like the vector database. And that's where, like right now, it's very popular for startup to actually work on building a new vector database, or like building on top of a vector database. So, okay, so now we understand in a way, how did we come up with the idea of the autocomplete? Then we had the idea of the transformer, and then we came up with a supervised fine-tuning. Yeah, so reinforcement learning, human feedback, and so on and so forth, until we came out to the idea of a vector. So now we are in a place where the ChatGPT is now having all these tokens, all these ideas. You could ask it a question, you could ask it all sort of interesting stuff, and you could come up with very creative and then very logical and understandable type of answers. The final topic that I'll talk about, and I promise this is the last one, which is the idea of a neural network. This is a very nice diagram that I found on the internet. We have talked about all this beauty that the ChatGPT is doing with text, but now you could see that a lot of LLM can actually understand images, could actually generate images, could actually understand text and images, and so on and so forth. So what I'm trying to do here is like in a very like high level, just give you the idea of how did we came up with the idea of turning an image into a text, and then text to an image. So this is the human neuron, and then basically this is a cell. You've got the dendrites for the input, and then you've got the exon for the output. And what this is that it is like we try to replicate this human cell and build it into an artificial wall. So we've got this circuit, and then we've got input for this circuit and then an output. So what this circuit has, it has so let's say, for example, a human eye sees a line, okay? So at the start of the line, it is getting input, and it goes through, and while you're looking at the line, and then you are getting more and more feedback, and then until there is a threshold within this neuron that actually get triggered, and I was like, oh, I know what I'm looking at. That's a line. So what this is trying to replicate is a very similar idea. So you get A1 as an input, A2, A3, which are in the digital world, could be pixels or of a camera. And then these inputs all go into this cell, and then they add up more and more until the cell reaches a threshold that was like, oh, actually, I know what I'm looking at. I'm looking at a line. So we, in a way, replicated what the human brain is doing. We built that into into computers using a logical circuit and then some input, and then it would give me an output if it reaches this threshold. So, and of course, because the world is full of cats, what this is doing is that, so each one of those nodes is actually looking at a piece of the image. So let's say that the first one is actually looking at the ears, right? So the first one says, start to look at the start of the ear with A1, A2, A3, and it says like, oh, I think these are ears. And then the next one again. So the first one says like, oh, I know what I'm looking at. I'm looking at ears. The next circuit will say like, okay, I'm looking at the eyes. Next says like, I'm looking at the body. And of course, this is just 3, but in reality, it's like a lot much more bigger. And then it sees that it finds a tail. So it goes through deeper, and that's why I call like deep neural network. It goes into the next level, and then this level is looking for the input from this circuit, and this one is saying like, I see ears, and I see eyes, and I see a body. This one says like, I see a tail. So this level says like, oh, I think I know what I'm looking at. It's an animal. It still doesn't know what is it until it reaches the final level. The final level with all of these inputs, it is actually looking at all this input, and it's like, that's not any animal. Because of the shape of the ears and the shape of the face, that's actually a cat. So we turn a very abstract idea, which is like an image with multiple pixels, into a trained model that it would actually go through these circuits, and then it would say like, oh, I know what I'm looking at. It's a photo of a cat. So to take this even a step further, I explained this just to tell you the idea of what is the diffusion model, which is something that helps us turn text into images, turn text into like a video or audio, depends. So the concept here is that this is the idea of a compressor. So like normally this is, you give it, for example, say this word, a cat jumping out of a window, and then you give this into an input. So what this algorithm is going to do is that it's going to try to compress this into this purple three blocks, but while we're trying to keep as much useful data out of the sentence. And we'll lose data because you're asking it to turn like 2, 3, 4, 6 words into 3 words. So it's going to lose some of the data, but it's supposed to be trained very well that it would be able to keep the meaning out of this data. So you compress it into these 3 blocks, and then you tell the model, can you decompress it? Can you tell me what did I give you? And it goes and it's like, oh, a pet is leaving the house. It is in a way accurate. It is a pet and it's jumping out of the window. It is leaving the house, but it's not the word that you gave it. But that's not a problem because in a context, for example, of an image or a video, it is, our eyes are adapted. If you see a glitch in it, you still know what is it. So the idea is that when we say, for example, intelligence is compression, so what that means, there is a theory that says that if you understand a topic really well and someone comes your way and is like, can you explain it to me? And they will ask you, can you explain it to me in a very short and condensed idea? So if you really know the idea, that would be super easy for you to compress it because you know it all. So what someone says like, okay, so if we get the Wikipedia and we try to compress it on and on, there's even a competition that the more you compress the Wikipedia, someone is willing to pay some money. But the idea is that the model that would be able to compress the idea and then give it back again without any loss would definitely need to develop intelligence. So in a way, that is what the model is trying to do. So like, for example, ChatGPT does not save the whole internet data. It doesn't have access to all the internet data. It has an idea of what this internet data is. It would sometimes, if it sees the same data on and on, it would be able to say like, okay, this is what you're asking me. But if you ask it something, it's not gonna pick out of a data and give it back to you again. Now we come to the idea of the diffusion model. So what did we do is that we wanted to teach the model to actually detect the images of cat with added, not actually detect, actually generate images of cats. So what did we do? We took the cat here, an image of a cat, and then we added a little bit of noise. And then we add this image with the noise. We give it to our model here, this one. So we give it to this model and then say, can you remove the noise from here? So like, this is just what the model is trying to do, right? It is, we give it the image, we add noise, and we ask it, can you remove the noise? What it would do, it would actually be able to give you back the image without the noise, because the noise, it would realize the values of these noise pixels that you added doesn't make sense in the picture, right? So it would detect that this is a face of a cat. And then you add even more noise, and it's like, can you detect the cat? Can you remove the noise, sorry. Does that again, bring it back to here. Until you end up with complete noise. And then it's like, can you remove the noise? It will try and will give you this image. Yep.
It's just the opposite of adding a watermark to an image.
Yeah,
Exactly the same. And if you actually squint your eyes, you can still see the cat.
Yes. Yeah, the model would be able to easily detect the noise because it knows that it doesn't make sense to be here. But what is really interesting is that if you take this this neural network that you're trying to remove the noise, this neural network now developed the idea to look for cat faces. So if you take this this model that actually worked through removing the noise from this image, that you turn it to this and then turn it back to this one, each time you give it this noise, the model will be looking for cat faces, even if it doesn't exist. And it's so eager to get reward, it would start to make up stuff to say like, oh, this is noise, but I know that, I think it's a cat face. Let me actually tell you how. And it would actually start to generate a cat face. But the thing is, that's not the same cat face that we started with. That's a different face. So, and you do the same with the same model that was learned here, and then it will start to, you give it a complete noise, it would take it all the way and then generate a cat face because it is looking for a cat face. It doesn't have to be the same face that it started with, but you now trained a model to actually create an image of a cat out of noise. And again, this is, oh yeah. What is very interesting new. Yeah, so what we did now, for the same model that we used to actually train it on the cat faces, we added this text, which is a cat staring at me, okay? And then we took this one, we took this image, we added the text of a cat staring at me, and then we did the same, added noise and asked the model to remove the noise. But each time it's doing that, it's not just learning that it is removing the noise out of the image, it is also associating that with the word a cat is staring at me. And you do that the same, you add the a cat is staring at me, and then you give it add more noise, ask the model to remove the noise. It does that, but again, with the association that this image actually a cat staring at me, and again, until you reach the full noise. It is at this phase, it is with complete noise, but it's still not that this noise is actually a cat staring at me. So now what we have is a model that we started with training it on adding noise, then asking it to remove this noise, and then out of noise, it would generate images. But because we added the context of text, what we ended up with is a model. You would say, can you create an image of a cat staring at me? And it would immediately know, it would take it all the way through and then generate the image of a cat. So that's all I had for today. And yeah, thank you. Do you have any questions?
So when you say that we ask a question according to that model get trained, right? So you deploy any model into the organization and different users are querying on that model. So how that context gets set means that model training will be according to behavior of different users, right?
So the model that actually you are using, you can't fine tune it. So the model you're using now, it doesn't train. So that when you fine tune it, you have access to the model, and then you give it this small little bit of data, and then you ask it, go train on this data, and then it comes back to you. The model that, for example, when you use the model right now, this is this is something called like a retrieval augmented generation, where you have a set of data. You tell the model, I'm going to ask you a question about where did Ahmed park his car, right? And it has this data in a database. It doesn't know the answer to this, but it knows that it knows what a car is, knows what Ahmed is, and then it goes and they say, like, okay, I don't have this data, but maybe it is provided to me. So it goes to this data that you give it for your company data, goes through it, and I was like, okay, I know because it goes, this data says like, where did Ahmed normally park his car? Comes back to you. It doesn't need to be trained on what is the meaning of the word Ahmed or the meaning of the, but it goes through your data and then find the answer that it doesn't have in its data. So yes, to answer your question, when you talk to a model, it doesn't, you can't fine tune it by the questions of people unless you are given that possibility. I think, Daniel, we can fine tune it now, right?
You can fine tune some models, but A, does not add new knowledge to the model.
Yep.
Important, cannot inject new knowledge. It is only there for changing behaviors and performance profiles of models. And it's not a cheap exercise.
Yep.
Fine tuning is expensive. You have to do it over and over and over again. And there's very little good reason to do it. You use grounding, you inject meta context into the prompt, inject your knowledge into the prompt. You do it.
Yes. So when I fire a query on the API by passing my context and query using LangChain, at that time, will it use my context for the training, or it will just be for that reference purpose only?
The models are stateless. They will instantly, as soon as the outputs come back to you, forgotten it all. It's not stored in Azure. This is Azure itself I'm talking about. It's not stored by Microsoft except for the content safety stuff. The models are not retrained using your data, at least not from Microsoft side. The Azure OpenAI side, the models are not retrained by that you pass in.
When we had the conversation last night about loading a document, and so you base your answer on that document. So if you ask a question, but the temperature, I guess, based on this document, then you'll get the answer. Is that all in some way?
Yeah, of course, on the Azure OpenAI version, and even if you go into OpenAI playground, I think, yep, you could change the temperature. But if you would like it to give you accurate answers, you'd put a temperature on something reasonable. You don't want it to be very monotone and yeah, boring. But in the same time, there is a flow. So you would program this LLM. It says like, if you don't have the answers, actually go and check your data that I provided. And if you find it, then you just retrieve this data and then give me the answer. So is that your question, or did you have something? Okay. Guys have questions? Someone online? Happy?
There's no questions online, just me talking to myself.
All right. Thank you, everyone. And yeah.
There's still some pizza left if you want to take
Yeah.
some pizza.
Take pizza. Otherwise,
But it's the one with
the
pineapple.
Microsoft launchers will.
Anyway.
Yeah,
Oh, that's
it's only
a
pineapple
lot.
left, right? Yeah, see, that correlation there again.
Me saying the Microsoft vultures will swoop in.
Trim that bit off.
Actually, we know. We know.